Okay, guys, this is solving a system of two or more linear inequalities. All right, so here we go. Solving a system of two or more linear inequalities. Here we are with two inequality equations. I should say just two inequalities. And we are going to solve them by graphing. So what I did was, first of all, you should pause this video and write this down. Okay, it's kind of dim. Let me see if I can get this to come in any clearer. There we go. So I'm going to take this first inequality and I'm going to put it into, right now it's in standard form and I want to put it into slope-intercept form. So I'm going to move the x over. Divide everything by 2. So now we are in slope-intercept form. Remember, anytime you divide by a negative number, the inequality switches direction. So it would go from a less than to a greater than, dividing or multiplying by a negative number. But we didn't do that here. We divided by a positive number. So remember, to plot a line, we start off with the y-intercept. Put a point there. That's our starting point. Then we apply the slope. So here we have a rise, so we're going to go down 1 and right 2. The negative goes on only one of the numbers, not both. So down 1, right 2. Down 1, right 2. Follow that same pattern until you get a few points. And the equal sign tells us that we're going to have a solid line versus a dashed line without an equal sign. Okay, so we have a solid line here. Okay, maybe you remember from Algebra 1 that if it's a less than, we shade below. But this is a more advanced class, and we want to know why. So we're going to pick a test point. So I like to choose 0, 0. It's an easy number to plug in. So plugging in a test point to find out if I shade below or above, we're going to use 0, 0. So 0 in for y, 0 in for x. And simplifying each side, we get 0 is less than or equal to 4. And this is true. 0 is less than 4. So that means that 0, 0 is a solution to this inequality. So we would shade in that direction. If it was a false statement, we would need to shade the other direction. Okay, so now let's go ahead and graph the second one. So we're going to start off by moving the 2x to the other side by subtracting it. And then graphing this equation. Here we have a y-intercept of 4 again. We're going to put our integer over 1 so that we have a slope in rise over run format. So down 2, right 1. Down 2, right 1. Follow that pattern a few times. Now notice there's no equal. So since there's no equal here, we are going to use a dashed line. Now it's real helpful when solving a system graphically that you use different colors just to help you visualize this a little bit better. Now, since it's greater than, we would shade above this line, but let's go ahead and use a test point. This time, we'll use 0, 0 again. Okay, which is over here. So remember what I said, it's greater than, so we would shade above it. So this 0, 0 should not work. Let's find out. So plugging in 0, in for x and in for y. Okay, we will get 0 is greater than 4. Is that true or false? False. So 0, 0 is not a solution. So we would shade on the other side. So now we're going to be shading above this line. Okay. So now, where is the solution? It's going to be where they overlap. So all the points in here are solutions to this system. And keep in mind that if the border is solid, then solutions are located on the border as well. If the border is dashed, there are no solutions. So no solutions on the border that's dashed, but we do have solutions on the border that's solid. Okay? All right. And by the way, this point right here, what do you think? Solution or not a solution? That is the question. You tell me. Come up and tell me, yeah, that's a solution, or no, that's not a solution, and make sure you know why. Okay? All right. So that is 2. So we have solved this graphically. Any point inside here is a solution. Any point on the solid border is a solution. Let's go and jump to 3. So let's add on another inequality. We'll call this one y is greater than or equal to 1. So adding on a third linear inequality, we're given the y-intercept. And in this case, the slope is 0 because the x is missing. In order for the x to go away, it would have had to have been multiplied by 0. So we're going to have a horizontal line going through 1 on the y-axis. So here's 1, drawing in our horizontal line because it has a slope of 0. Now in this case, it's greater than, and guess what I did? I made a mistake. It's an equal sign, so this needed to be solid, not dash. Solid. Okay? Solid. We only need to plug in y values as a test point because there is no x here. So let's plug in a y value of 2. That would be right here. Is 2 greater than or equal to 1? Yes. So in this case, we would be shading above it. So for the system of 3 inequalities, now the solution lies where all 3 of them overlap. So the solution would lie in here. It would also lie on this border, because this is solid. And it would lie on this border, because this is solid. And I'm still waiting to find out about this point from you. And not any point on this dash line. Okay, so this video is actually 6 minutes less than the first one I made. Come to class prepared with your questions, and I'll see you all in the morning.